tall building project do you most admire, and how would you emulate that in a future project, or how would you improve upon them?
It's a very big question.
Yeah.
Yeah, for me, because but actually, I love the architecture standing on the turning point of the history of architecture. For example, Chicago architects invented a skyscraper, so-called skyscraper. So I admire their work very much. And also, Miss van der Rohe's glass tower is very impressive because it was invented, maybe first invention of the aesthetics of the curtain wall. So I'm very admire his work very much. And also, you know, the Ken Yang is a Malaysian architect. He was maybe the first architect to employ the green technology in high-rise buildings. So I admire his work very much.
And what about Ken Young's work, the green technology that you mentioned?
Because until then, before his work appearing, all the architects only think about the outside or exterior or the shape of the building itself. But in his case, he tried to make a new kind of shape with using the windows or environment and the sunshine, such kind of thing. Maybe when you design a housing project, it sounds very natural, but no one thought about we can use such kind of technology in a large scale building. So I admire his work very much.
Do you think that wood will become a primary building material for tall buildings in 10 years?
Oh,
and why
I want to say
why
yes.
not?
I want to say yes because actually I have designed some high-rise building with using wood much. So for me, it looks very old material, but with the help of the computational design and so-called digital fabrication, as you know, it's very easy to cut and process by CNC machine or something. So I think those wood could be a very brand new material for the high-rise building near future.
And what sort of benefits do you think that will confer?
Because it's a natural product, every people like it, and also it's a very not so heavy, so everyone can move and remove from the architecture itself. So usually when you design a very large building, you can use metal or concrete. Those materials are very heavy. So once the construction work finished, it's very difficult to remove from the architecture. But if you use the wood, maybe it's very easy to change. So from now on, we have to think about the sustainability of architecture. So I think wood is a very suitable material for that kind of purpose.
Right now, it's still pretty rare, but do you think in 10 years it'll be common, or will it take more time?
I strongly believe so. Maybe less than 10 years, we start to use wood more in large-scale architecture.
Because of the sustainability concerns.
That's right.
So let's talk about BioSkin.
Yes.
BioSkin's an active system for managing the environment in a building, the microclimate, I guess, of a tall building. Can you tell us just how it works and why or why not it would make sense for other projects?
It's very difficult to explain in one word, so but anyway, I'll try. It's a system using the heat of evaporation. As you know, in Japan and some other Asian country, we have a very rich rainfall in summertime. But our sewage system is very poor, so we cannot throw it away in rainy days. We have to preserve it in a basement or something using some kind of the preservation tank. And in a sunny day, we pump it up to throw it. So it means waste of the water and electricity both. So I try to use the rainwater flow in the pipe, ceramic pipe. During that process, rainwater penetrates the surface of the ceramic pipes, appear on the surface of it. It starts to evaporate, and it gets rid of the large amount of the surface, heat of the surface of the architecture. And if we think about the heat island phenomenon, it caused by architecture works as a kind of the heat mass. So if we install the BioSkin on the architecture or buildings, we can get rid of the larger amount of the heat itself using the heat over evaporation. So I think it's a very outline of what is BioSkin.
Do you think it's a system that can work in many other buildings, or is it specific to the climate in which it is?
Basically, in all the place, we can get the heat and we can get the rainwater. So I think basically it can work in every architecture. But we have to take climate into the consideration very deeply because it's very sensitive system. So it's a very fragile system. When we use it correctly, we have to understand the climate very deeply.
So BioSkin, I would maybe call it an active system.
Yes.
But does it also work with passive design, or is it sort of separate from it?
Oh, I think BioSkin is a very active product, but it's based on the very primitive phenomenon, heat over evaporation, I mean. So I think all the green material or green elements should be based on the both sides, active and passive. So if we succeedingly take in both sides of the effect, maybe we can make the very durable system. So I think for me, not only one aspect, but also two aspects is very needed when we think about the green design.
Is BioSkin affordable? What's the payback period like? Does it save building owners any money?
As I said, BioSkin is based on the heat over evaporation. In the Sony City's case, we use the handrail. Handrail is made by ceramic pipes. So I can say the initial cost is zero because handrail is needed. So only what we have to pay is a small electric pump, like maybe 10,000 yen or $10,000 or something. It's very cheap. So I think from the viewpoint of the payback, as soon as we complete the construction work, it's also already payback. So we don't need to worry about that. Also, but from the viewpoint of the energy consumption, BioSkin can reduce about 2% of the total energy. So building is very big, so it means energy or cost of the energy is very big. So even if it can reduce only 2%, it means a very big money. So I think I should say it's a very affordable and it can pay back very soon.